In this lesson, we are going to be using substitution and elimination to solve three variable systems. Not only are we going to be solving for x and y, but now we're also going to be solving for z. Example 1. Notice in this example we have three equations with x and y and z. If you look at the three equations carefully, one thing that from the very beginning, we know that z is equal to x minus 3. That's set up for substitution. So what we're going to do is we're going to use that for equation number 2. So equation number 2, we have 3x plus z equals 17. If I know that z is equal to x minus 3, then I'm going to replace this z with x minus 3. Now we can solve for x. I can combine like terms. 3x plus 1x is 4x minus 3 equals 17. And then continue to solve for x. I'll add 3 to both sides. Now we have 4x equals 20. Divide by 4. We end up with x equals 5. Once you have the first solution, plug it in and find the second solution. So I can go back to either of the first two equations. The first equation is probably the easiest. We have z equals x minus 3. And since we know that x equals 5, I'll plug in 5 for x. So 5 minus 3 is 2. Z equals 2. Now that I have x and z, I can plug both of those in to figure out what y is. Now, the only equation that has y is the third equation. So I'm going to take the third equation, x minus 3y plus 5z equals 24. And I'm going to plug in 5 for x. And I'm going to plug in 2 for z. Now we can go through and figure out what y is. So if I do my multiplication here, 5 times 2 is 10. So I'm going to rewrite this. 5 minus 3y plus 10 equals 24. And combine like terms. I have 5 plus 10. That's going to be 15 minus 3y equals 24. Now that we've cleaned up our equation a little bit, we can get y by itself. So this is a positive 15. We'll subtract 15 on both sides. It's going to leave me with negative 3y equals 9. And then to get y by itself, divide by negative 3 on both sides, and we end up with y equals negative 3. If you wanted to write your answer as a coordinate point, remember to put it in order: x, y, and then z. So if we wanted to write this as a point, we would have 5, negative 3, 2. Example 2. Again, here we have three equations with three variables. We want to figure out what x is, what y is, and what z is. Well, looking at the three equations, I don't see an x by itself, I don't see a y by itself, I don't see a z by itself. So this really is not set up for substitution. However, it is set up to do elimination. And so the big question is, what should we eliminate? Well, if you look at the third equation, in the third equation, there is not a z. There's no z in the third equation. So what that tells me to do is to get rid of all of the z's. So we are going to take these first two equations here, and we're going to eliminate z. So I'm just going to rewrite them. X plus 3y minus 2z equals 8. And 3x minus 4y plus 2z equals 8. And I'm going to get rid of z's by adding these two equations together. So if I add everything together, of course the z's, negative 2 plus 2 is 0, so the z's are gone. And everything else, I've got 1x plus 3x is 4x, 3y plus negative 4y, 3 minus 4 is negative 1y, equals 8 plus 8 is 16. Okay, so now I have this new equation here, and if you notice, this equation that we just created has x and y. Looking back at the original 3, that last equation also has x and y. So we're going to bring that last equation and stack these together. 4x minus 5y equals 16. And we're actually just going to eliminate again. Now here I have positive 4x and positive 4x. We really just want one of those to be negative. So we'll just pick one. We can multiply maybe the first row if we want to multiply this first row times negative 1. Then that would be negative 4x plus y equals negative 16. The second row, I'm going to leave that the same. 4x minus 5y equals 16. Now all we have to do is add these two equations together. Negative 4x plus 4x is 0, so the x's are gone. And we can add 1y plus negative 5y. 1 minus 5 is negative 4. And negative 16 plus 16 is actually 0. And we can solve for y from here. Negative 4y equals 0. All we have to do is divide by negative 4. And we end up with y equals 0. All right, so we have one of our answers. Once you have one answer, go back and plug it in to find that next answer. So if we know what y equals, looking back at those original 3 equations, I'm going to have to plug it in to the third equation because the third equation only has 2 variables. So if I go back to that third equation, remember that third equation over here, 4x minus 5y equals 16. If I know that y is 0, then I'm just going to plug in a 0. Now, 5 times 0 is 0. So this is just going to be 4x equals 16. To get x by itself, we can divide by 4. And we get x equals 4. Now I know what y is, I know what x equals, I need to figure out what z equals. So you can use, back in the beginning, you can use either of those first 2 equations because they both have x and y and z. And it does not matter which one I use, we can just use the first one. So the first equation was x plus 3y minus 2z equals 8. Now I know that x is 4, so I'm going to replace the x with a 4. I know that y equals 0, so I'm going to replace the y with a 0. So if I bring this down, let's see, 3 times 0 is 0. So I'm going to have 4 minus 2z equals 8. And to get z by itself, this is a positive 4, so we will subtract 4 on both sides. That leaves us with negative 2z equals 4. And then last, to get z by itself, divide by negative 2 on both sides, leaves us with z equals negative 2. All right, if you want to write this as a coordinate, you would always put x first, and then y, and then z. So our x value is 4, our y value was 0, and our z value was negative 2. So that's an example of solving a 3-variable system using elimination. Let's try one more. Here again, we have 3 equations and 3 variables. We want to solve for x and y and z. If you look closely at the 3 equations, all 3 of them have x and y and z. and they're actually all lined up for elimination. So look at the x's, look at the y's, look at the z's. Which variable should we eliminate based on the way this is set up? Yeah, they all have 5z. There's negative 5z in the first equation, positive 5z in the second equation, and negative 5z in the third equation. So what we're going to do is take two at a time and eliminate those z's. So for starters, I'll do the first two equations. We'll do 3x plus 2y minus 5z equals 0. And the second equation, x plus 3y plus 5z equals 11. And we're just going to add these together because if you have negative 5z plus 5z, that's 0. So we're going to add these together in order to cancel out the z's. So going through and adding everything else, we have 3x plus 1x, that's going to be 4x. 2y plus 3y is going to be 5y. And over here on the other side, 0 plus 11 is 11. Now that's the first two equations. I'm also going to do the second equation and the third equation because this one, middle one, has a plus 5z and the last one has a minus 5z. So I'm basically going to take the same approach. I'm going to eliminate the z's for the second two equations. So equation 2, we had x plus 3y plus 5z equals 11, and 4x minus 8y minus 5z equals 14. And just like we did in the last step, we're just going to add these two rows together because we have 5 plus negative 5 is 0. If we go through and add everything else, 1x plus 4x, this is going to be 5x. 3y plus negative 8y, 3 minus 8 is negative 5y. And on the other side, 11 plus 14 is 25. So I've gotten rid of the z's everywhere. That's narrowed it down to where up here we have x's and y's only. And down here, the new equation we created also has x's and y's only. So now we're going to eliminate again. We're going to pull those two equations together. 4x plus 5y equals 11. And 5x minus 5y equals 25. And we're going to eliminate again. Now, this is nice because it's already set up for us. Look at those y's. You have a positive 5y in the first equation, and you have a negative 5y in the second equation. It's already set up for elimination for us. If we add these together, 5 minus 5 is 0. So go through and add everything else. 4 plus 5, that's going to be 9x. And on the other side, 11 plus 25 is 36. So to get x by itself, I have a little baby equation here. We just divide by 9, and we get x equals 4. Whew, okay. So a lot of work to get that first answer, but once you have that first one, you're just working backwards and you're just going to go plug in that x equals 4 to figure out the rest of your missing variables. Now in this particular example, I don't need to go back all the way to the because we have x and y and z for all of those equations. I'm actually just going to work back one step, and I can either use this equation I created here that has x and y, or I can use the equation that I created up here that has just x and y. It doesn't matter which one you use. I'm actually just going to use that top one because it has all positive numbers. So I'm going to bring that down. We've got 4x plus 5y equals 11. I know now that x equals 4, so I'm going to replace the x with a 4. And we're going to go through and solve for y. So 4 times 4 is 16 plus 5y equals 11. To get y by itself, we'll subtract 16 on both sides. That'll be 5y equals negative 5. And here to get y by itself, I can just divide by 5. And we end up with y equals negative 1. All right, now we know what x equals. and we know what y equals, we can take both of those back to the very beginning and use any one of these equations to figure out what z equals. I'm going to choose the second equation just because it has all positive values. So x plus 3y plus 5z equals 11. I know that x is 4, so I'm going to put a 4 here. I know that y is -1, so I'm going to plug in a -1 for y. And we're just going to go through this and figure out what z equals. So bring down that 4. 3 times -1 is -3. Combine like terms. 4 minus 3 is 1. And to get z by itself, this is a positive 1. We'll subtract 1 on both sides. Now we have 5z equals 10. Divide by 5 on both sides. We end up with z equals 2. So we have our solution here. If we want to write it all together, make sure you put it in order, x, y, and then z. That would be 4, -1, and 2.